Hello everyone. This is in continuation with our hypothesis testing related problems. This is the next problem. Uh, it's about test for more than two population means. So we will be using one-way ANOVA. We will be seeing what it is. A research company has designed three different systems to clean up oil spills. The following table contains the results measured by how much surface area in square meters is cleaned in 1 hour. The data were found by testing each method in several trials. Are the three systems equally effective? Use 5% level of significance. So they gave us data about the three different systems and how much square meters are being cleaned within 1 hour. That is what is the data. So since there are three systems, it is concerned with the three different population means. So more than two population means becomes, we'll be using what is called as F test. And for that, we will be doing one-way analysis of variance. So let me first write down the above. The above is a test concerning with more than two population means. Hence, we will use F test. Okay, then we are going to find out whether all the three systems are equally effective. And here, only in row, they gave you the headings like system A, system B, system C. They didn't give any heading for the columns, what situation, what parameters, etc. So we will be doing a one-way ANOVA or one-way analysis of variance. Wow. For that. So for that, primarily we will be defining about the population means. So let mu A is the population mean, population means surface area cleaned in 1 hour using system A. Same way, mu B is the population mean surface area cleaned in 1 hour using system B. And we define for C also, population mean surface area cleaned in 1 hour using system C. So once we define this population means, we can now create the or freeze on the hypothesis. So H naught, which is null hypothesis, will be all the systems are equally effective. That means we'll say there is no significant difference between mu A, mu B, and mu C, which means mu A is equal to mu B is equal to mu C. That is nothing but no significant difference, between the three systems, That will be our null hypothesis. Alternative will be, even if two of them are not equal, it will become an alternative hypothesis. So at least two of the above are not equal. That will become your alternative hypothesis. Now, the data is given, which are all in 2 digits. We can think about simplifying it. For example, each data, I can take something somewhere in the middle number, I can assume it as 57. So let the origin to be taken for the data given as 57. Means I'm going to subtract all these observations with the 57 to simplify the data, nothing else. So the same table is given here. 55 minus 57, it is minus 2. 60 minus 57, it is 3. 63 minus 57, it is 6. Likewise, I can write all the values. So it is minus 2, first value, then 3, second value, then 6, third value, minus 1, 2, minus 2. Total of that, if I add it, I will get 6, then 0, then minus 4, then 7, then minus 8, then 5. Total of this particular row, we will get 0, and then we will have the next value as 9, then minus 5, then 4, then 0. For this, the total will be 8. Let us create one more row for the grand total calculation. So I'll add this, which is I will get as 14. So merge it and write it as grand total. So we have the, what do you call, each row totals and also the grand total for this. So very first, what do you call, very first step will be to find out what is called as correction factor. Shortly CF, that is nothing but grand total square divided by the number of observations. So here the grand total is 14 the square, and the number of observations, if you look into first row, is I got 6 values, 5 values, and 4 values, means 6 plus 5, 11, 11 plus 4, 15. So 15 values of the observations. That will give you 13.07 as the correction. That is the very first step. The next step is to find out total sum of squares. Sum of squares, shortly TSS. It is nothing but individual observation squares, means minus 2 the square, plus 3 square, plus 6 square, plus and so on. The last value is 0. I can ignore it because if I square it, it will be the same. I will keep only up to 4. 4 the square. This whole thing minus the correction factor. So if we evaluate this value, we get 320.933. That is total sum of squares. The next step is to find out row sum of squares. Row sum of squares, shortly written as RSS. What is that? Individual rows total the square, means 6 square. Then how many, this 6 is made out of how many observations? 6 observations. So I have to divide it by 6, plus the next one is 0 square by 5 observations, that is made out of 5 observations. Then 8 square by 4 observations. This entire total minus the correction factor. If we calculate this, we will get that value as 8.933. So we got now total sum of squares and row sum of squares. The next step is to find out error sum of squares. Which is ESS. that is calculated as total sum of squares minus row sum of squares, which is 320.933 minus 8.933. The result will be 312. So once we arrive at these values, we can now create what is called as ANOVA table. Where the format of that ANOVA table will be like this. So here between rows, degrees of freedom. How many rows are there? There are 3 rows. So the degrees of freedom will be 3 minus 1 less. So it is 3 minus 1. So it becomes 2 degrees of freedom. Now the total observations, number of observations were 15. Here degrees of freedom will be 1 less. It will become 14. Error degrees of freedom will be the balancing figure. So 14 minus 2, which is nothing but 12. This is, how did we get this? This is whatever is the total minus the total degrees of freedom minus the rows degrees of freedom. You get the error degrees of freedom. Sum of squares for rows is 8.933. Sum of squares for error is 312. Total sum of square is 320.933. Now, mean sum of squares, how do we calculate? It is 8.933 divided by 2. Let's calculate that. 8.933 divided by 2. You get 4.4665. And then error sum of squares is 312 divided by 12. We get 26. So therefore, the F ratio will be this row sum of squares, mean row sum of squares divided by mean error sum of squares. That ratio. So 4.4665 divided by 26. What is that? At 0.172. Now, table value we are supposed to identify for the numerator degrees of freedom. Numerator is 4.4665. The corresponding degrees of freedom is 2. And then denominator is errors mean sum of square. Corresponding degrees of freedom is 12. So 2, 12 degrees of freedom. We need to check for the corresponding level of significance. Level of significance is given in the question as 5% or 0.05. Let's check that value on the tables. F tables we have to check. For 0 point level of significance, numerator degrees of freedom is 2 and the denominator degrees of freedom is 12. So we get to 3.89 as the table value. Now here itself we can write the inference since I can mark this. Since F calculated, this is nothing but F calculated value. F cal, which is 0.172, is lesser than F tab, which is 3.89. We accept null hypothesis. Means there is no significant difference between the 3 different systems as far as the cleaning time is concerned or the efficiency of the cleaning is concerned. That will be the interpretation or inference for this particular problem. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my